At 2:46 in the afternoon, the ocean floor off the coast of Japan moved 50 meters in about 3 minutes. What came next crossed the entire width of the country in half an hour. Not a wave in the way most people picture one. A moving wall of black water, in places over 30 meters tall, carrying ships, cars, and entire buildings inland like debris in a current. By the time the water receded, nearly 20,000 people were dead or missing. 90% of Japan's coastal sea walls, structures built specifically to prevent exactly this, had failed. Here's what almost nobody outside Japan knows happened next. Over the following decade, in near total silence, Japan built something that has no real precedent anywhere on Earth. A 400-kilometer concrete and steel barrier running along its northeastern coastline, engineered section by section against a threat most countries wouldn't even know how to model, let alone survive. This isn't really a story about a wall. It's a story about what happens when a nation gets caught catastrophically unprepared and then has to prove, to its own citizens and to the rest of the world, that it still has the institutional capacity to make sure it never happens again. To understand why Japan responded to this disaster the way it did, you have to understand what actually happened on March 11, 2011, with the same factual precision any serious documentary account owes its audience. At 2:46 in the afternoon local time, a magnitude 9.0 earthquake struck off the northeastern coast of Japan's Tohoku region, the most powerful earthquake ever recorded in the country's history, and one of the 5 most powerful ever measured anywhere on Earth. The rupture occurred along a subduction zone, the boundary where the Pacific tectonic plate grinds slowly beneath the North American plate. In this instance, that boundary didn't just shift. Over a stretch of fault roughly 500 kilometers long, it snapped violently, displacing an enormous volume of ocean water directly above it in a matter of minutes. That displacement is what generated the tsunami. Waves radiated outward from the rupture zone at the speed of a commercial jet, reaching the nearest sections of Japan's own coastline in under 30 minutes, barely enough time for emergency sirens to sound, let alone for coastal residents to reach higher ground. When the water arrived, it didn't behave the way tsunamis are often depicted in disaster films, as a single dramatic breaking wave. Survivors and researchers alike describe something closer to a rapidly rising, unstoppable tide of black water, in places measured at over 40 meters in run-up height when it met the shape of certain coastal valleys, funneling and amplifying as it pushed inland. The human toll was severe and needs to be stated plainly, without embellishment. Official counts place the number of dead or missing at close to 20,000 people, the large majority of them in coastal communities directly in the tsunami's path, rather than from the earthquake's shaking itself. The disaster also triggered a severe accident at the Fukushima Daiichi nuclear power plant, when the tsunami disabled backup cooling systems and led to a partial meltdown, a separate and significant chapter of this story in its own right, and one this video isn't attempting to cover in full, since our focus here is specifically on the coastal infrastructure response that followed. What matters most for understanding everything that came afterward is a single stark engineering fact. Japan, going into March 2011, was not an unprepared nation in any general sense. This is a country that has spent well over a century developing some of the most advanced earthquake and tsunami engineering standards on the planet, born directly out of repeated historical experience with exactly this kind of disaster. Japan already had extensive networks of coastal seawalls, breakwaters, and floodgates in place along its northeastern shoreline before 2011, many of them built after previous tsunamis in the 20th century specifically to prevent a repeat of those earlier disasters. And in the moment that mattered most, roughly 90% of those existing coastal defenses failed. Not because the engineering behind them was careless or unsophisticated by the standards of their time. They failed because the 2011 tsunami exceeded the design assumptions those structures had been built around, in some locations overtopping walls by many meters, in others eroding foundations from behind after water crested the structure and came down on the landward side with tremendous force. One of the most sobering individual failures involved the port town of Kamashi, home at the time to what had been certified as the world's largest and deepest breakwater, a structure that had cost over $1 billion and taken decades to complete. It was substantially destroyed in a matter of seconds, offering only a partial delay to the wave rather than the protection its scale had promised. Yet even within that widespread failure, one story stood out clearly enough that Japanese engineers would later treat it as a genuine blueprint. In the town of Fudai, a local mayor had, years earlier, insisted on building a floodgate and seawall considerably taller than government guidelines recommended at the time, over significant local objection to the cost. When the 2011 tsunami arrived, that oversized structure held. The town's population survived almost entirely intact, one of the only coastal communities in the entire disaster zone to do so. That single decision, made by one local official willing to spend more than his neighbors thought necessary, became the seed of an entirely new national engineering philosophy. Build for the disaster you haven't seen yet, not merely the one your records already describe. That philosophy is what set the scale of everything Japan would go on to build over the following decade. And the sheer scale of that undertaking is difficult to overstate. It's worth pausing here on one more point of context, because it shapes how seriously the rest of this story should be taken. Japan sits atop one of the most seismically active regions on the planet, at the junction of 4 major tectonic plates, and its written historical record of major earthquakes and tsunamis stretches back well over 1,000 years. This wasn't a country encountering the concept of a tsunami for the first time in 2011. It was a country with an unusually long institutional memory of exactly this threat, extensive prior investment in coastal defense, and decades of engineering research specifically dedicated to the problem. And even with all of that accumulated preparation, the natural event still overwhelmed nearly every physical barrier standing in its path. That's the detail that should recalibrate how you think about the scale of what comes next in this story. This wasn't a nation starting from zero. It was a highly capable, highly experienced nation that had just been shown, in the most brutal way possible, that its own definition of prepared needed to be rewritten entirely. So here's the scale of the response Japan actually committed to, once that new philosophy took hold at the national level. Rather than repairing the failed seawalls piecemeal, section by section, along whichever stretches of coastline happened to have the most damage, Japan's national and regional governments committed to something categorically larger. A continuous engineered coastal defense system running approximately 400 kilometers along the Tohoku shoreline, the equivalent of the distance between New York and Boston, doubled. The total cost of the project has been estimated at over $12 billion, funded almost entirely through national reconstruction budgets rather than private investment, treated from the outset as a core function of the state rather than a discretionary infrastructure upgrade. To put that scale in perspective, this isn't a single wall in any conventional sense. It's closer to 400 separate, individually engineered structures, stitched together into one continuous line of defense, each section designed specifically for the geology, wave exposure, and community layout of that particular stretch of coast. In places, the wall stands over 14 meters above the waterline, taller than a typical 4-story building. But the visible portion, striking as it is, doesn't tell the full engineering story. A substantial part of each section's structural mass sits below the surface, anchoring the wall against exactly the kind of undermining and erosion that destroyed so many of the original 2011 defenses. Coordinating a project at this scale required breaking the work into manageable pieces, and Japan's approach to that division reveals something specific about how the country chose to manage risk on a project this large. Rather than awarding the entire 400 kilometers to a small handful of major contractors, the project was split among roughly 440 separate construction teams and contractors, each responsible for a defined section of coastline. That structure carried real risk of its own. If even one of those hundreds of contractors ran into financial trouble or fell badly behind schedule, it could leave an actual physical gap in an otherwise continuous line of defense, a weak point that would undermine the integrity of the whole system regardless of how well engineered the neighboring sections were. Managing 440 simultaneous, tightly specified construction sites along an active and often hazardous coastline for the better part of a decade without a single point of total failure was as much a logistical and administrative achievement as it was an engineering one. Before a single design decision was finalized, engineers spent extensive time modeling wave behavior along every planned section of the new wall, running each design through hundreds of computer simulations to understand how differently shaped stretches of coastline would channel and amplify wave energy under a range of future tsunami scenarios, not just a repeat of the specific 2011 event. That modeling directly shaped the final structure. The wall's height was never treated as a single uniform number repeated along the entire 400 kilometers. It varies meaningfully from kilometer to kilometer, built taller on exposed headlands that would face the most direct wave impact, and comparatively lower in sheltered bays where the surrounding geography naturally reduces wave energy before it ever reaches the shore. Beneath the surface, the engineering challenge multiplied further. Survey teams drilled and tested the seabed along the entire planned route before construction began, because the ground itself changes character constantly along 400 kilometers of coastline. In some sections, engineers encountered soft clay, entirely unable to support standard construction equipment. In others, dense sand, and in others, solid bedrock, each demanding a completely different foundation approach and a different construction method entirely. There was no single template that could simply be repeated along the whole length of the project. Every section, in a meaningful sense, had to be engineered as its own distinct structure, sharing a common design philosophy, but built to the specific physical reality of its particular stretch of shoreline. This is, in other words, not a story about one dramatic wall rising out of the ocean in a single continuous act of construction. It's a story about an enormous, distributed national effort. Hundreds of contractors, thousands of engineers, over a decade of continuous work, all coordinated toward a single unifying goal, proving that the state could translate the trauma of catastrophic failure into a system precise enough and disciplined enough to actually hold the next time. It's worth being clear about what made a project of this scale possible in the first place, because it says something specific about the kind of state capacity this required. This wasn't primarily a private engineering achievement, financed by markets betting on future returns. It was a sustained act of public investment, authorized through Japan's national reconstruction budget and coordinated across multiple layers of government, national ministries setting design standards and funding allocations, prefectural governments managing regional priorities, and local municipalities negotiating the specific footprint of the wall through their own communities, in some cases against real local resistance from residents who worried a wall. This toll would permanently separate them from the ocean views and fishing access that had shaped their communities for generations. Reconciling those local objections with a national engineering mandate, section by section, across 400 kilometers of coastline, without stalling the broader project for years, was itself a demonstration of institutional capacity most governments simply don't have occasion to test at this scale. Understanding how a wall like this actually gets built, physically, from nothing tells you almost as much about institutional discipline as the funding and the politics do, because at every stage, the margin for error was treated as effectively zero. Construction began, in nearly every section, with demolition. Before anything new could rise, engineering teams had to study exactly how each stretch of the original 2011 seawalls had failed, whether by direct overtopping, by erosion undermining the foundation from behind, or by outright structural collapse under wave impact, and then clear away what remained. That failure analysis wasn't a formality. It directly shaped design decisions for the replacement structure at that exact location, since a wall that failed from backside erosion needed a fundamentally different foundation treatment than one that failed from direct frontal impact. The physical construction itself had to work within a genuinely narrow operating window. Along much of this coastline, tidal patterns gave construction crews only a few hours of exposed, workable seabed each day before the water returned, meaning every minute of low tide had to be planned and used with precision rather than treated as flexible working time. In the sections built on soft coastal clay, the ground itself couldn't support the weight of standard construction machinery at all. Crews addressed this by laying temporary steel road plates across the unstable ground, distributing the weight of bulldozers and excavators across a wider surface area so the machines could effectively float above mud that would otherwise have swallowed their wheels entirely. Some of the most demanding work happened entirely underwater, in the active surf zone, in the same ocean that had just demonstrated exactly what it was capable of. Divers guided multi-ton boulders into position to build the submerged foundation base of each wall section, working at depths where visibility was limited and conditions could change with the tide. Engineers monitoring this underwater work from the surface relied heavily on sonar imaging rather than direct visual inspection, meaning a considerable amount of trust had to be placed in instrumentation and data rather than first-hand observation. A level of technical confidence that itself reflects decades of accumulated underwater construction experience specific to Japan's coastal engineering tradition. Once each foundation mound broke the surface, construction moved into a phase requiring extraordinary attention to compaction and material precision. Fill material was added in carefully measured layers, each one compacted to a specific density standard before the next layer could be added. If a layer failed to meet that density threshold, independent inspectors had the authority to halt work on that section entirely until it was corrected, regardless of how far behind that might put the overall schedule. This wasn't a bureaucratic formality either. An improperly compacted foundation settles unevenly over time, which would gradually tilt the wall itself out of its designed alignment, quietly undermining structural integrity in a way that might not become visible until the next major wave event actually tested it, at which point the flaw would be catastrophic and impossible to correct in time. Above the foundation, thousands of massive precast concrete panels, some individually weighing several tons, were manufactured, transported along narrow coastal roads, and fitted into place along the wall's face, each one engineered to interlock precisely with its neighbors through embedded steel reinforcement, so the completed structure would behave as one integrated wall rather than a line of individually stacked blocks with weak points at every seam. Woven throughout the entire structure, largely invisible to anyone simply looking at the finished wall from a distance, is a dense layer of engineered redundancy. Drainage systems designed to safely channel away any water that does eventually top the wall during an extreme event, rather than letting it pool destructively against the landward face. Specialized geotextile fabric layers that let water pressure equalize through the structure without allowing fine soil particles to wash out and destabilize it internally. And at every river mouth and low-lying gap along the 400 kilometers, automated floodgates engineered to seal shut within roughly a minute of a seismic sensor detecting a qualifying earthquake, closing under battery backup power even in a total electrical grid failure, without requiring a single human being to manually operate them in the critical seconds before a wave might arrive. None of these individual measures, the compaction standards, the interlocking panels, the automated gates, would mean very much in isolation. What makes this system genuinely different from what existed in 2011 isn't any single engineering innovation. It's the fact that every one of these redundant safeguards was designed, tested, and inspected as part of one integrated system, built specifically around the failure modes that destroyed the previous generation of defenses, rather than simply rebuilding a taller version of the same basic structure that had already been proven insufficient once. One additional layer, placed offshore in front of many sections of the main wall, illustrates this philosophy particularly well. Massive interlocking concrete armor units, each weighing tens of tons, are placed along the seabed, not in a precise, uniform grid, but essentially dropped in a controlled but somewhat random pattern, allowed to settle into their own naturally stable configuration. The engineering logic here inverts the instinct most people bring to construction. The gaps between these units aren't a flaw to be minimized. They're the actual mechanism doing the work, letting incoming wave energy pass through and dissipate across thousands of small chaotic collisions rather than slamming as one undivided force directly into a solid wall face. It's a deliberately imprecise structure engineered to absorb precision-scale destructive energy. Chaos, in effect, engineered into order. A wall like this can be engineered with extraordinary precision and still remain, in a real sense, theoretical until it's actually tested by the exact kind of event it was built to withstand. Japan didn't have to wait especially long to see how the new system would perform. In March 2022, roughly a decade after construction began along the Tohoku coast, a magnitude 7.4 earthquake struck off the same general region the 2011 disaster had originated from, not on the scale of the original catastrophe, but a genuinely serious seismic event in its own right, and importantly, one large enough to trigger the exact automated response systems built into the new coastal defenses. Seismic sensors detected the quake and triggered the network of floodgates along the coastline to begin closing automatically, without waiting for a human operator to issue that command, exactly as designed. Engineers monitoring the wall's instrumentation afterward reported no significant cracking in the concrete panels and no shifting in the offshore armor units, a result substantial enough that it registered within Japan's own engineering community as a genuinely meaningful validation of a decade of design decisions, rather than simply an uneventful non-story. That's a critical distinction worth sitting with for a moment, because it says something important about how this kind of infrastructure actually gets judged. A seawall doesn't get a ribbon-cutting ceremony and public celebration the way a bridge or a stadium might. Its entire purpose is to be tested by exactly the kind of event nobody wants to see arrive at all, and its success is measured, if it's measured at all, by an absence, by the disaster that didn't happen, by the flooding that didn't reach the streets behind it, by casualty figures that stayed low enough that the story barely made international news. That's a strange kind of infrastructure to evaluate, because the clearest possible proof of its value is also the least visible, least newsworthy outcome imaginable. Beyond any single test event, Japan built ongoing verification directly into the system's operating philosophy, rather than treating the wall's completion as the end of the engineering process. Embedded sensors monitor sections of the wall continuously, tracking subtle shifts in settlement and structural strain over time, feeding that data back to engineers who watch for the kind of gradual, almost imperceptible changes that, left unaddressed, are exactly what caused some of the original 2011 defenses to fail quietly from within, long before the tsunami ever tested them directly. Independent inspectors retain ongoing authority to flag and demand remediation of any section showing signs of unacceptable settlement or deterioration, years or even decades after construction is technically finished. And every year, on March 11th, Japan conducts nationwide disaster drills specifically timed to the anniversary of the original earthquake and tsunami. Emergency response teams, coastal monitoring centers, and local governments all rehearsing the exact sequence of decisions and actions the real event would require, deliberately keeping the institutional memory of 2011 active and current, rather than letting it fade into a historical footnote as the years pass and the people who lived through it gradually age out of positions of authority. That's a small but telling detail about how seriously this is being treated at the institutional level. This isn't a wall that got built once and then forgotten. It's a system that Japan has committed to actively retesting its own readiness against every single year, indefinitely. There's also something worth noting about how this infrastructure has settled into the daily texture of life along the coast, separate from its emergency function entirely. In many towns, the top of the wall has become a genuine public space, a walking and cycling path where residents exercise, walk dogs, and move through their daily routines, effectively turning several hundred kilometers of tsunami defense into an ordinary piece of civic infrastructure that people interact with constantly without necessarily thinking about its original purpose at all. That's not a minor footnote. It reflects a specific choice about how disaster infrastructure should relate to the communities it protects, not walled off and militarized, but integrated into ordinary civic life, present and visible, without being oppressive or constantly anxiety-inducing for the people living behind it. That said, it would be incomplete and dishonest to the spirit of a journalistic account to treat this story as an uncomplicated triumph without qualification. Some residents and independent researchers have raised genuine, documented concerns about the project, including whether walls of this height in certain locations have disrupted coastal ecosystems, altered fishing access that some communities depended on for generations, and in some cases simply blocked the ocean views that had shaped how residents related to their own coastline for their entire lives. Engineers have also cautioned, publicly and on the record, that no wall of any height can be considered an absolute guarantee against every conceivable future event. A wall built to withstand a specific range of modeled scenarios could still, in principle, face something that exceeds even this generation's more conservative and more carefully modeled assumptions. That caveat isn't a criticism of the project. It's the same intellectually honest posture that produced the project in the first place. Build for the worst case you can reasonably model, while remaining clear-eyed that certainty in a field like this is never fully available. Step back from the engineering details for a moment, and a bigger question comes into focus, one that reaches well beyond concrete and rebar. What does it actually mean for a country to respond to catastrophic failure the way Japan did here? Every nation on Earth eventually gets tested by something it didn't fully prepare for. An earthquake that exceeds the building codes, a flood that overwhelms the levees, a storm that outpaces the evacuation plan. That kind of failure, on its own, doesn't distinguish one country from another in any meaningful way. Nature doesn't grade on a curve, and no amount of institutional competence makes a nation immune to being surprised by a large enough event. What actually separates states from one another isn't whether they get caught unprepared. It's what happens in the years immediately afterward, when the emergency has passed and the harder, slower, far less dramatic work of rebuilding begins, usually with far less public attention and far less political urgency than the disaster itself commanded. That's the lens this entire story is really asking you to look through. Building 400 kilometers of precisely engineered coastal defense, coordinated across 440 separate contractors, funded through a sustained national budget commitment over the better part of a decade, without losing political will partway through, and without a single section becoming an unaddressed gap in the line, requires a specific combination of capacities that most governments, even wealthy and technically sophisticated ones, rarely have to demonstrate all at once. It requires the financial capacity to commit tens of billions of dollars to a project with no direct revenue return, justified purely on the grounds of protecting human life and coastal infrastructure. It requires the technical and scientific capacity to model an enormous range of future disaster scenarios with genuine precision, rather than simply rebuilding a taller version of whatever existed before. And it requires the administrative capacity to coordinate hundreds of simultaneous contractors across multiple layers of government over many years, while maintaining a level of quality control precise enough that a single poorly compacted layer of fill or a single defective concrete panel could halt an entire section of work until it was corrected. Very few of the physical objects involved in this story are genuinely unique to Japan. Concrete panels, seismic sensors, automated floodgates, offshore armor units. These are all technologies available, in some form, to any sufficiently developed nation on Earth. What Japan actually demonstrated here wasn't a monopoly on engineering knowledge. It was the sustained institutional will to apply that knowledge at a national scale, continuously, for over a decade, without the project quietly losing priority. As the initial shock of the disaster faded from daily headlines and public attention moved on to other concerns, the way disaster response so often does elsewhere once the emergency phase passes and the cameras leave. This is where the story connects back to something worth naming directly, because it's really the underlying thesis running through everything in this account. Physical infrastructure, at this scale, isn't simply a practical response to a physical problem. It functions as a visible, measurable proof of a state's actual institutional capacity, its ability to convert money, technical expertise, and political will into a durable physical outcome that will still be standing and still functioning decades after the original crisis that prompted it has faded from global memory entirely. A country's geography exposes what it's vulnerable to. What a country actually builds in response reveals what kind of state it really is, underneath the political rhetoric and the disaster relief press conferences that follow every emergency in every nation on Earth. Not every country facing a comparable threat responds this way, and it's worth being clear-eyed about that, without singling out any specific nation for criticism here. Coastal defense projects around the world are frequently underfunded relative to the actual risk they're meant to address, delayed by shifting political priorities across changing administrations, or scaled back once the immediate memory of the triggering disaster fades from public attention and the political cost of continued spending starts to outweigh the political benefit of visible action. Japan's response stands out specifically because it didn't follow that far more common pattern. The commitment held consistently across multiple changes in national government, across a full decade of sustained construction, all the way through to a system that has already been tested once by a real, if smaller, earthquake, and held. That's the actual achievement sitting underneath 400 kilometers of concrete, steel, and compacted fill. Not merely a wall tall enough to stop a wave. A demonstrated proof that when a modern state is shown, in the most brutal and public way imaginable, exactly how unprepared it truly was, it can still convert that exposure into a sustained, disciplined, genuinely enormous act of institutional will. And that in an increasingly unstable world, growing more prone to compounding natural disasters and infrastructure stress of every kind, That specific kind of institutional capacity may end up mattering just as much to a nation's real power as the size of its economy or the strength of its military ever has. It's worth stating plainly what this story is not claiming, because the temptation with an account this dramatic is to overreach. This isn't an argument that Japan has somehow solved the problem of natural disaster, or that any wall, however well engineered, makes a coastline permanently safe under every conceivable future scenario. It's a narrower and, in some ways, more useful claim that the gap between a state's stated values and its demonstrated capacity becomes visible precisely in moments like this one, when disaster strips away the comfortable ambiguity of ordinary politics and forces, a direct, expensive, unglamorous choice about whether protecting citizens is actually worth the sustained cost of doing so properly. If you've made it this far with me, thank you, genuinely. This is exactly the kind of story I built this channel to tell. Not the 5-minute headline version, but the slower one, where you actually understand what a piece of infrastructure reveals about the institution that built it. If that's what you're after, consider subscribing and joining us. We do this every single day. All right, back to it. Because there's a question worth sitting with before we leave this coastline behind, and it's one I suspect some of you are already asking. If a wall this carefully engineered can still be tested and possibly exceeded by some future event nobody has modeled yet, was any of this actually worth $12 billion and a decade of national effort? It's a fair question, and the honest answer isn't a guarantee. It's a bet made with the best available science that the cost of over-preparing for a threat this severe will always be smaller than the cost of being caught unprepared a second time. Japan already knows, with brutal specificity, exactly what that second cost looks like. Nearly 20,000 people. Entire towns erased in under an hour. That's not an abstraction here. It's the baseline this entire project was measured against. What makes this story worth telling isn't really the concrete or the steel at all. It's the fact that this kind of sustained, unglamorous, multi-decade institutional follow-through is rare enough, globally, that when it actually happens, it says something specific and measurable about the state capable of doing it. Most disasters get a wave of attention, a round of promises, and then a slow fade back into ordinary politics long before the rebuilding is actually finished. Japan's coastline is one of the clearer counterexamples to that pattern currently standing anywhere on Earth. And that's exactly the thread this channel is going to keep pulling on going forward. Because coastal walls aren't the only kind of infrastructure a state builds to prove it can survive the thing that's supposed to break it. Nations bury command centers deep underground. They build continuity of government systems designed to survive strikes that would end lesser states entirely. They construct entire cities meant to keep functioning after the exact kind of catastrophe this video just walked through. That's where we're headed next. Here's what stays with me about this story, long after the concrete and the compaction reports fade into the background. At 2:46 in the afternoon, on an ordinary Friday, a country got a 15-year lesson in exactly how wrong its own definition of prepared had been. 90% of its coastal defenses, structures built by serious engineers to serious standards, simply failed. Nearly 20,000 people didn't survive the hour that followed. There is no framing of that fact that makes it anything other than what it was. What happened next is the part worth carrying with you. Not a press conference. Not a temporary patch job on the sections of coastline that failed most visibly. A 400-kilometer commitment, engineered kilometer by kilometer, funded across a full decade, inspected down to the density of a single layer of fill, tested once already by a real earthquake, and found to hold. Nobody in Fudai, The one town whose oversized wall survived intact in 2011 could have known their mayor's stubborn insistence on building taller than the guidelines required would become the blueprint for an entire nation's response a decade later. But it did. One decision, made against local objection, quietly became doctrine. That's the part of this story that reaches past Japan, past tsunamis, past concrete specifications entirely. Every nation eventually gets shown, in some form, exactly where its own preparedness ends and its own vulnerability begins. Geography guarantees that much for everyone, sooner or later. What isn't guaranteed, anywhere, is what a state chooses to do in the years immediately after that exposure, once the emergency has passed and the cameras have moved elsewhere. When rebuilding properly is expensive, slow, politically unglamorous, and easy to quietly deprioritize in favor of whatever crisis arrives next. Japan chose to rebuild as if it might be tested again by exactly the same order of magnitude, or worse, and to keep retesting that choice every March 11th indefinitely, long after global attention moved on. That's not an engineering story anymore, not really. It's a story about what a state actually is, once you strip away everything it says about itself and look only at what it was willing to sustain, year after year, when almost nobody outside its own borders was still watching. If this is the kind of story you want more of, subscribe and share it with 5 people who'd actually sit through something like this. Leave a comment. Tell me honestly what you thought, and tell me what you want to understand next. Because somewhere out there, another state is being quietly tested right now by the thing it least expected, and how it responds will say more about its real power than anything printed on a map.